Modern threats to the OT environment include attacks directly targeting the Industrial Control System, or ICS. This is problematic when considering the role an ICS may play in society and the very real potential consequences, up to and including loss of human life and devastating long-term environmental damage. One recent example of the threat to the OT environment is the destructive malware Shamoon. At a high level, the attack quietly spreads to several assets and later synchronously wipes the hard drives of the infected assets. Human-machine interfaces, or HMIs, are the points where humans interface to control the industrial control processes, and these are vulnerable to this attack. The following will demonstrate a model behavior of the destructive malware and the recovery-oriented workflow developed by the systems development team. Cobalt Strike is used as the threat emulation platform to deploy beacons that hook IT assets in the path to critical infrastructure machines in the OT environment. The target machines are hooked, and a custom malicious executable is copied to each machine on the path. Then a task is scheduled to run the destructive executable that wipes each hard drive. As the video just showed, each machine restarts and boots into the destructive malware, and the destruction of the hard drives begins. Once the destruction is finished, each machine goes to a black screen, and the malware's task is complete. As part of the defensive workflow, Microsoft System Center Operations Manager, or SCOM, is used to provide cyber situational awareness. SCOM is a component of the System Center suite designed to monitor operations and services of enterprise infrastructure systems. SCOM provides the ability to monitor health and performance of systems and report issues and errors back to the manager. SCOM can distribute alerts based on health and performance of machines monitored. In this scenario, SCOM is listening to critical machines for a heartbeat. When critical infrastructure machines don't send the heartbeat within the timeout specified, a critical alert is generated as shown. For each of these machines, this alert is forwarded to the security orchestrator swim lane, creating a record and starting the workflow. The record creation and swim lane starts the workflow of the re-imaging process. A record is a filled-in template associated with an application. An application is made up of both the template and a workflow. Swim lane will take the inputs from the record, such as host name, port, IP, and firewall configuration files, and pass them to the integration pieces as needed throughout the workflow. The integration pieces include any communication between swim lane and another appliance, such as a dark node, SCCM, and the management machine doing the forced restart. For the first step in the workflow, swim lane issues a command to modify the configuration of the dark node firewall. A dark node is a physical appliance that encrypts traffic between any two given dark nodes. It also acts as a rudimentary firewall. The workflow changes the firewall configuration to allow a PXE boot and block all other traffic. The PXE boot is performed by Microsoft System Center Configuration Manager. Microsoft SCCM is a solution designed to reduce administrative tasks by providing comprehensive configuration management. SCCM provides the ability to construct custom deployment packages to proactively manage the entire lifecycle of Windows devices across an enterprise. SCCM can be used as a central location in an enterprise to provide applications and updates, remediate compliance settings, and remotely capture and image computers. To perform the PXE boot and re-imaging, the machines are put into the PXE Restored Systems collection in SCCM for re-imaging. A forced restart is issued to allow the compromised machines to PXE boot and start the re-imaging process. Swim lane will periodically check to see if the re-imaging is done by checking the alerts in SCOM. Once the alerts disappear for the compromised machines, then the image is finished downloading and installing, and the HMI is presumed to be in a known good state. After the re-imaging is finished, swim lane issues a command to SCOM to remove the HMIs from the Pixie Restore System's collection. Lastly, the firewall rules on the dark node are changed back to the original configuration, and each machine is again ready for use. This concludes the demonstration for automating a defensive workflow in an IT/OT environment. Thank you for watching.